So once again, we're looking at a system of 3 equations and 3 unknowns, and we want to use an augmented matrix to solve the system of equations. I've gone ahead and rewritten our system of equations as an augmented matrix. Again, you just take the coefficients, and those go in rows on the left-hand side of the line, and then the constants go on the right-hand side of the line. The line represents an equal sign. So our first step, as always, is we want the first row, first column to be a 1. Well, it's already a 1, so we don't need to change that. Our next step is we want the second, in the next steps, we want both of the first column and the second and third rows, so our -2 and our 1, we want to make those zeros. So let's start with our second row. How do we make that second row, first column, 0? Well, we can use either the first or third rows, multiply it by 2, and add it to the second row. I'm going to use our first row. So let's go ahead and write our first row out again. 1, -2, 2, 1. And then we want 2 times our first row, so 2, row 1. We want to add that to row 2. So 2 row 1 plus row 2. So 2 times 1 is 2, plus -2 is 0. 2 times -2 is -4, plus 1 is -3. 2 times 2 is 4, plus -1 is 3, and 2 times 1 is 2, plus 2 is 4. We'll rewrite our third row, -1, 1, 5. And now we want this 1 in the bottom left-hand corner, our first column, third row, or third row, first column. We want this 1 to be 0. So in order to do that, let's go ahead and we'll rewrite our first 2 rows, since we're leaving those the same for our third step. 1, -2, 2, 1, 0, -3, 3, 4, and then -1 times row 1, so negative row 1 plus row 3. So -1 plus 1 is 0. -1 times -2 is 2, plus -1 is 1. -2, so 2 times -1 is -2, plus 1 is -1. And then -1 plus 5 is 4. So now we've gotten a 1 in our first row, first column, and zeros underneath it. So what is our next step? Our next step is we want the second row, second column to be 1. So in order to do that, let's write our matrix down again. Our first row stays the same, -2, 2, 1. Now we want this -3 here to be a 1, so we multiply by -1/3 row 2. 0 times -1/3 is 0. -3 times -1/3 is 1, which is what we wanted. 3 times -1/3 is -1. And 4 times -1/3 is -4/3. And then our last row remains the same, 0, 1, -1, 4. So what's our next step? We have a 1 in the second row, second column, and now we want a 0 below it. So we want this third row, second column to be a 0. How do we do that? Well, if we multiply our second row by -1 and add it to row 3, then we'd end up with -1 plus 1, which would be 0. So let's go ahead and do that. I'll write out our first row, 1, -2, 2, 1, 0, 1, -1, -4/3, and then -1, or negative row 2, -1 times row 2, plus row 3. So -2 times 0 is 0, plus 0 is 0. -1 plus 1 is 0. And then negative negative 1 would be 1. Minus 1 is 0. And then 4, or negative 4/3 times negative 1 is 4/3. Plus 4, that's 12/3. So 4/3 plus 12/3. Or 4/3 plus 4 times 3 is 12 over 3. So 4 plus 12 is 16/3. But now we're looking at something that I referenced when we were looking at two equations and two unknowns. We have 0, 0, 0, 16/3. Well, what does that mean? That means that that equation is now 0x plus 0y plus 0z equals 16/3. But 0 times x is just 0, 0 times y is just 0, and 0 times z is just 0. So in effect, what this means is 0 equals 16/3. But that's false. So this is like when we were solving using elimination and substitution without using matrices. We end up with the variables falling out and an untrue statement. So what does that mean? It means that this system is inconsistent and that there is no solution. So if you end up with a row of zeros and a constant, that means every time that the system is inconsistent and there is no solution.